Natural disasters. They can strike without warning. Savage reminders of our fragile existence. Shattered lives. Ravaged property. If you make it through alive, you hope you'll never again face nature's fury. Earthquakes and floods, tornadoes and hurricanes. These catastrophes shake our very foundations. Sometimes they happen in the blink of an eye. Sometimes they're slow, relentless death. National Geographic takes you to Bangladesh, Mexico City, the American Midwest. All over the world, nature's unleashed power kills thousands of people and leaves thousands more to pick up the pieces in despair. Will fighting these natural-born killers always be a losing battle, or can we learn to survive nature's fury?
Where there's smoke, there's fire. And where there's a volcano, that's where you'll find Maurice and Katja Kraft. From Iceland to Hawaii, these death-defying scientists risk their lives in hot pursuit of active volcanoes. Their tools are cameras. Their mission is to capture nature's most powerful spectacle on film. Join National Geographic on this unforgettable journey to the edge of the volcano.
This is the bottom of the ocean, an ocean of air as vast and volatile as any sea. Above the Earth's surface, currents ebb and flow. Some spiral into whirlwinds. The dust devil has more bluster than bite. Other twisters are downright deadly.
Tornado on the ground on 944. Cars split. We got numerous people injured. Get away from the windows. Tree just blew over. Wow, look at that tree over there. Look at that pile. Get away from the windows. Get away.
Tornadoes pack the fastest winds on Earth. But in magnitude, this spinning giant goes unmatched. Hurricane, typhoon, cyclone, all equally fearsome. By any name, the greatest storms on Earth. Severe tropical storms afflict every continent except Antarctica. In this century, they have claimed over 500,000 lives. Tornadoes have killed over 10,000 in the United States alone. Today, electronic eyes pierce the atmosphere and map its shifting winds. Scientists chart the anatomy of a storm. Their sensors record speed and bearing.
Make it the same level as the tripod.
But none can predict the birth of a killer. Nothing in our power can stop the fury of nature's whirling winds. Early spring, 1991. A southern sun heats the waters of the Gulf of Mexico. Warm, moist air rises and travels northwest over Texas, Louisiana, and on toward the central United States. More than 1,000 miles away, cool, dry air rushes south from Canada. Rising over the Rockies, dry upper-level air flows east, then spills onto the Great Plains. These forces collide over Tornado Alley on Friday, April 26, 1991. Fast winds high above the ground over slower winds below make the air roll horizontally like a pencil on a tabletop. The atmosphere is unstable. Thunderstorms erupt across the plains. Here and there, an updraft lifts the horizontal spinning of the air into a vertical position. Now the storm rotates as it feeds on warm, moist air near the ground. The day gives rise to supercells, the most complex and dangerous thunderstorms on Earth. Their underbellies bubble with instability. Lightning and hail are the least of their threats. Under the right conditions, they can also spawn monsters. The National Weather Service has tracked the warning signs for a week, predicting severe weather. By April 26, the conditions are textbook perfect for a major outbreak of tornadoes. Throughout the afternoon and evening, across the central states, 56 twisters are reported.
In the Hayesville area to get some more information on that tornado.
Honey, be careful.
It's going to be around 55th South and
Is it going away from us?
Officers are reporting maybe
Marty.
10 to 15 houses in Hayesville that have been damaged
Marty.
by the tornado.
Is it going away from us?
They're saying that there's going to be damage in the area of 55th and Broadway and also 53rd Street South.
I sure hope you're right.
Then, at 5:57, a killer touches down in Kansas. In Wichita, residents are sitting down to dinner when warnings send them running to basements and storm shelters.
Look at the stuff floating in the air, Ginger. Take cover.
Around 6:20, the tornado takes on a pinkish hue as it pulverizes a nursery full of geraniums. By the time it hits McConnell Air Force Base, the twister is nearly 300 feet wide. Base hospital, school, rec center, and over 100 housing units are leveled. 6:29. In Andover, the town siren fails, but most residents heed warnings by police and news reports. tornado's funnel has widened to almost 600 feet. At 6:40, it tears through the Golden Spur Mobile Home Park. The twister finally dissipates northeast of Andover. Within minutes, its parent storm drops another funnel along the Kansas Turnpike.
Can you get in the left lane, Greg? Yeah. Oh, that didn't help us. Go back. You're okay, you're okay. Keep going, man, keep going.
Faster?
No. Yeah. Lots faster, lots faster.
A local TV crew tries to outrun it.
Lots faster, Greg, it's catching us. You gotta go, buddy.
Even at 85 miles an hour, they can't get out of its way.
Get up under here.
They stop at an overpass where a father and his two daughters run for cover.
Hang on to the girder. Don't worry about it. Hang on.
As the twister spins out its final moments, a dread calm takes its place.
We need some place to sit down.
Along the turnpike, people are pulled from trucks and cars tossed like children's toys. Andover is hardest hit. In what was the Golden Spur Mobile Home Park, 10 bodies are found. Kansas bears a bitter toll. Over 1,700 homes destroyed or damaged, and 20 dead. Survivors will never forget.
The car was hovering. It was about 3 foot off the ground, just sort of floating in the air. Then all of a sudden, the car left and went right out the roof.
What looked like typing paper floating around was really not. It was like
Garage doors.
And window frames, parts of houses.
Ambushed on a country road, Brooke Ibarra took shelter under the nearest tree. In a flash, she was airborne, then dropped 1,000 feet away.
The cows all of a sudden started running like a stampede. I was picked up by the tornado, and there was all sorts of debris. One thing I remember was the cow that flew past me. He was screaming. And then before I knew it, it was over, and I was just laying in the field next to a tractor engine.
Wounds are healed, neighborhoods rise from the rubble. The human spirit endures. Such is life in Tornado Alley, USA. Midwesterners once called them cyclones. Early photographs and motion pictures held viewers spellbound. Tornadoes begat their own myths. Some claimed they fused coins in people's pockets and cooked potatoes in the ground. In truth, they make airborne missiles of everyday objects. Some have deposited heirlooms 40 miles from home. Do they pluck feathers from chickens? No. Blame that on sheer fright. They inspire no less terror in people. April 3rd and 4th, 1974. In the largest outbreak on record, 148 tornadoes race across 13 states. March 18th, 1925. The deadliest tornado in history leaves the longest path. 219 miles of continuous devastation, 689 dead. Until the 1950s, accurate tornado wind speeds remain a mystery. Then a frame-by-frame analysis of this footage clocks flying debris at 170 miles an hour. Tornado science takes a leap forward in 1953 when Dr. Ted Fujita leaves Japan for the American Midwest.
The main reason why we are here is to find out what tornado did. And in case of future tornadoes, what people should do, that's the kind of thing we want to find out.
4 decades of research will earn him the title Mr. Tornado.
That, I think, it's a grain elevator up here.
At disaster sites, Fujita proves there's much to be learned without braving a twister directly. He likens tornadoes to criminals who leave their fingerprints behind. Ground markings are clues to a twister's inner structure and dynamics. To test his theories, he builds a tornado machine at the University of Chicago. He discovers that most strong tornadoes are actually several small twisters rotating around the center of a larger one. These mini tornadoes can lay waste to one house, yet leave its neighbor unscathed. Fujita's ideas have been amply confirmed in nature and remain a cornerstone of tornado science. Although they occur around the world, 3 out of 4 tornadoes streak the skies over the United States. They favor the springtime and the warm hours between noon and sunset. We say a tornado touches down. It actually sucks in air from near the ground and carries it upward in a spiral. Most range from 150 to 1,200 feet in width and travel over land at about 30 miles an hour. The funnel is often hollow, a tube of condensed water vapor that takes on the color of dust and debris. In North America, most tornadoes rotate counterclockwise. Perhaps 1 in 1,000 spins in the opposite direction. Twisters appear in many guises. They can bring to mind the snapping of a bullwhip or the delicate dance of ghosts. A single storm can spawn several distinct funnels, a grouping referred to as a family. For all their fury, most tornadoes are short-lived. Many last only minutes. To the scientists who would study them, they are elusive prey. How to penetrate the twister's secrets? Aiming weather balloons and instrumented rockets into tornadoes have yielded limited results.
See whether we can. All right. 3, 2, 1. Fire. There. Nope.
In the 1980s, researchers at the National Severe Storms Lab tested the Totable Tornado Observatory, nicknamed Toto, after Dorothy's dog in The Wizard of Oz. This 400-pound package of sensors was to record what no human can even approach without risking life and limb. But predicting the path of a tornado proved to be nearly impossible. Toto had one close call, no direct hits. For now, the safest way to see inside tornadoes is to probe them from afar with Doppler radar. Like an X-ray of a storm, the system displays wind speed and direction. In 1981, scientists first detected the spiraling signature of a tornado on Doppler radar. Today, the system is used to issue warnings to the public. Still, we're not exactly sure why twisters form at all.
We probably could produce a higher base storm.
For Howard Bluestein, professor of meteorology at the University of Oklahoma, there's only one way to find out.
Satellite pictures are nice, radar pictures are nice, but you need to look out the window and see the clouds in their very, very fine scale to get a feeling for what's happening. I don't understand how one can study a phenomenon without actually experiencing it, seeing it or feeling it or tasting it. To me, that sets everything in motion. That makes me want to understand why it's there, what causes it, what's going to happen to it. They just issued a tornado warning for right where we are.
Should we set up?
Every spring, Bluestein exercises two considerable talents: chasing tornadoes and measuring them with the latest technology. Portable Doppler radar is like a meteorological magnifying glass. It allows Bluestein to measure wind speed in very fine detail in specific regions of a tornado.
Okay, we've got to get going quickly. That thing is starting to form a nice funnel. Actually, hold it. Can you turn it on?
Oops, up power.
It's starting to form a funnel, and it's not that far away.
I'm on the left side of that tight circulation.
Bluestein's success rate is better than most storm chasers.
The funnel cloud is just to our north-northwest. We're packing up the radar.
He estimates 1 in 9 expeditions ends with an encounter.
Okay, you got it? Yeah. Oh, tell me to take the pictures. Recorder starting.
Which mode are you in?
I'm in CW.
Okay, tornado is crossing the path of the radar.
Debris in the air.
Strong tornadoes almost always form under the southwest edge of a storm. Bluestein plots his course accordingly and tries to place his team roughly 2 miles from touchdown.
Zoomed out.
Just center the whole
I'm
thing.
zoomed in all the way. Now
Center it.
Oh, what a classic.
Should I go to FM?
Only if you have a good CW signal.
Look at the monitor.
Okay, yeah, that's good.
We're detectives, and we're looking for lots of bits of evidence. And the more pieces of evidence we have, the more likely it will be that we'll be able to solve the puzzle of why tornadoes form and what's their structure.
April 26, 1991. Bluestein and his team track the outbreak that will ravage Andover, Kansas.
Stopping, tornado.
Let's go.
A spectacular funnel stops them in Red Rock, Oklahoma. Their Doppler radar will capture the fastest wind speed on record, nearly 280 miles an hour. In the heat of the chase, even Bluestein can miss a beat.
Get out of here fast, let's go!
For less frenzied fieldwork, Bluestein turns to these hunting grounds, the Florida Keys. August 1993. The National Oceanic and Atmospheric Administration and the National Geographic Society reunite Bluestein with Dr. Joseph Golden, Expedition Chief Scientist. As a graduate student, Bluestein once joined Golden to explore the skies over Key West. This expedition marshals state-of-the-art scientific and photographic technology. The quarry? A phantom twister that haunts these tranquil waters. In 1967, on a vacation trip, Golden took a sightseeing flight over the Florida Keys and had a chance encounter with one of our atmosphere's most startling apparitions. Since that time, he has become the world's leading expert on waterspouts. Our knowledge of these ethereal ribbons was once based largely on mariners' accounts. Golden first emphasized their similarities to tornadoes. Though usually smaller than a twister over land, they form in gentler weather than most violent tornadoes, allowing close inspection. Smoke flares will help visualize airflow near the sea surface. For Bluestein, this is an unparalleled ringside seat.
When we're out in the Great Plains looking at tornadoes, we cannot see what's happening right at the ground very clearly, nor can we see what's happening at cloud base extremely clearly. The perspective that we get from the helicopter, in that we can look down at the sea surface and see the effects of rotation at the ground level, and also be at cloud base and practically kiss the condensation funnel. It's right outside the window, is really spectacular.
Ultimately, the ghostly waterspout may reveal the hidden forces that trigger tornadoes.
Joe, August climatology works. That was incredible.
Other whirling winds demand a more lofty vantage point.
Okay, Declan, as we approach the hurricane from the southwest, you can see we're flying with the...
Book a seat on the space shuttle for the perfect view of these monsters, over 500 miles wide and some 10 miles high. Creatures of the sea, they breed in the warm oceans of the tropics. Depending on their birthplace, we call them cyclones, typhoons, or hurricanes. These giants can stir up more than 1 million cubic miles of the Earth's atmosphere every second and travel across an ocean at up to 30 miles an hour. Yet they have humble beginnings. In the summer and fall, the sun heats vast stretches of tropical ocean to over 82 degrees Fahrenheit. Warm, moist air rises over these hot spots, forming bands of thunderstorms. Upper-level winds push storm systems westward as surface winds spiral into the low pressure beneath the clouds. Occasionally, one such spinning wheel of thunderstorms gathers strength, feeding on moisture and heat. When winds reach 74 miles an hour, a hurricane is born. The storm's architecture is highly organized. Rain bands up to 300 miles long converge in the most violent sector, the eye wall. Here, winds of up to 200 miles an hour spiral upward. Within the eye, downdrafts of dry air create an eerie calm. Most severe tropical storms spin out their lives uneventfully in the open sea. When one threatens to come ashore, the world's eyes are trained upon it, including those of Jim Leonard. A professional storm chaser, Jim checks forecasts religiously. He prowls the globe for weather that most people would simply flee. Among chasers, Jim has few peers. Some say he has videotaped more severe storms than anyone on Earth. He has no formal training, no college degree in meteorology, just a lifelong passion.
15F, you're all set.
Thank you.
You're welcome. When I was 10 years old, I had my first real hurricane experience with Hurricane Donna. We got probably winds of 80, 90 miles an hour. It was quite an exhilarating experience at that point. People think I'm crazy, but that's their own opinion. It's not going to change. I've always been crazy about storms, and I always will be. The best of them all probably was Hurricane Hugo. Went down to Puerto Rico and got a direct hit. And as it got stronger and stronger, debris was starting to be lifted off the parking lot, and it looked like it was going to get blown back toward us. So we decided at that point to start going down the stairway. As we're going down the stairwell, the rain is being driven into the walls, through the stairs, coming down the stairway, and the wind you hear squealing. At this point, it's probably in excess of 150 miles an hour. And that was quite an experience. It was like one of the chasers called it the hallway from hell. I have no reason to be in a storm if it's going to scare me. I'll get to the point, play the safe route as far as I can. But if I want to get that ultimate shot, of course you're going to take some chances.
1992, Typhoon Omar in Guam.
Is this a piece of wind or is it a piece of wind?
Yeah, really. I wouldn't miss a great eye wall like this for anything.
Jim and a fellow tracker have a close call as Omar's eye wall comes ashore. Now the storm's placid eye engulfs them.
It seems over. It really does, but it's not. We're going to get blitzed again.
I know.
I can't believe that we're going to get blitzed again. It just seems impossible. That was flabbergasting.
The unsettling lull does not last. Here, the trailing edge of the eye wall rushes in, with winds blowing in the opposite direction.
It looked like it was going to wait a few minutes.
Yeah, I know.
It wasn't coming on.
Yeah, if I knew it was this, I would have hurried more.
In 1991, Jim achieves a personal best.
Typhoon Uri, when it approached the southern part of Guam, I did a little bit of carelessness there, but I got the storm surge shots that I always wanted to get, but the water came up a little faster than I thought it would.
Winds and low pressure allow the sea surface to rise near the storm's eye. When it hits land, this mound of water rushes ashore.
That's what you call storm surge. We're in. Oh, great.
When the surge is waist deep, Jim retreats. He, more than most, knows that a hurricane's most deadly weapon is not wind, but water. Nine out of 10 hurricane victims are drowned by storm surges. They can raise tides more than 20 feet above normal and flood 100 miles of coastline under 10 feet of water. % of the world's population live at risk from severe tropical storms. Atlantic hurricanes assault the U.S., Mexico, and the Caribbean. Typhoons born over the western Pacific Ocean batter Japan, China, and the Philippines. Most deadly are the cyclones that strike Bangladesh. Here, millions farm a river delta in places only inches above sea level. Escape routes are few. Loss of life has been appalling. In a single 1970 storm, over 300,000 dead. " Of all the atmosphere's threats, these giants should hardly catch us off guard. Weather satellites track them from birth. But no technology can predict exactly where one will go. To penetrate the hurricane's secrets, researchers ride a flying laboratory into the eye of the storm.
David? Yes, sir. We're going to go in at 10,000 feet. At 10, no? Yeah, we're playing it safe. Looks impressive anyway. We have about 15 miles to the beginning of the wall here.
External sensors measure temperature, air pressure, humidity, and wind speed as the plane braves the turbulence of the eye wall.
I got 100 knots of wind now. Yeah, I thought it might drop off when it hit. Not yet? Up ahead, it looks like it probably won't. We may see some 200 knot gusts near 25 knot updraft. Okay, we're just coming into the edge now.
An oasis of calm, over 9 miles tall. The eye is virtually clear from sea to sky.
You guys see a center down below there? I think we're just about directly over it. Looks good. I think we got the center here. Okay, I'll mark it.
The eye's exact location and vital statistics are sent to forecasters on shore. Data also flows to this meteorological think tank, the Hurricane Research Division in Miami, Florida. What global ingredients determine how many hurricanes are born each year and what paths they follow? Stanley Goldenberg, research meteorologist, says clues range from the El Niño phenomenon to rainfall in Africa.
No, it's a little bit different. But it's still
He crafts computer models based on the premise that an organized piece of weather like a hurricane can be defined in mathematical terms.
The atmosphere is an orderly universe. There's physical rules, physical laws that govern these things. It's just a matter of having the right data, looking at it with the right tools and the right analyses. I mean, the real art is pulling the information out of the data.
Goldenberg helped refine one of the models the National Hurricane Center uses to issue forecasts. But he had never experienced a hurricane on the ground until 1992. On August 17th, Tropical Storm Andrew takes shape, about halfway between Africa and the Caribbean. During the following days, the storm slowly intensifies. Then high-level winds begin to tear Andrew apart, slowing its momentum.
Well, it's the slowest one.
Yeah.
But so say 3 days puts it here.
Yeah.
So by 4 days.
4 days.
Saturday, Sunday, Monday.
To Goldenberg and most other meteorologists, Andrew has only the slimmest chance of ever becoming a hurricane.
So we'll see.
Friday, August 21st. As high-level winds die down, Andrew begins to reorganize and quickly gathers strength. Computer models show Andrew might head towards southern Florida, but Goldenberg and his colleagues dismiss any immediate threat. Stan leaves work early to prepare for an important weekend. His wife, Barbara, is due to deliver their 4th child on Sunday. 750 miles from Miami, Andrew's winds exceed 74 miles an hour on Saturday, August 22nd.
Hurricane warnings in effect for Dade and Brown counties, and a hurricane watch is in effect for Collier County.
The first hurricane of the Atlantic season is born. By noon on Sunday, massive evacuations are ordered along the Florida coast. Sunday afternoon, right on schedule, Barbara has been in labor since around 6 a.m.
Well, here we have from the hurricane to the other action in this room, which is Barbara going through
Early stages of labor, over 4 centimeters contracted, going through labor pains.
In the birthing suite, Stan videotapes the proceedings with all the fervor of an expectant father.
Our nurse here.
Still, the meteorologist in him can't help but be distracted.
And we still have, waiting for the hurricane, beautiful skies, calm. You never know what was going to happen here in the next 12 to 14 hours or so.
Late in the day, Andrew's winds accelerate to 150 miles an hour. Traveling nearly due west, it descends upon the Bahamas. Around 6 p.m., it strikes Eleuthera Island, packing a storm surge 23 feet high, taking 4 lives.
Having a boy makes you feel like a father, and having a girl makes you feel like a daddy, right?
There you go.
Stan steals a few hours with the new arrival, Pearl, then leaves the hospital. He'll ride out the storm at home.
Hurricane to hit Miami.
In Miami, violent skies herald Andrew's approach. Inland, residents take routine safety measures. Seven miles from shore, Stan and his boys are joined by his sister-in-law and family.
Sunday, 23rd of August. We have the family here, Jonathan and Daniel, Roger, Benjamin, Joseph, Aaron, Reuben. We have Ann, and we're going to weather it out through the storm. Hi, Daniel, say hi.
In the dead of night, Andrew suddenly intensifies as it approaches the tip of Florida. August 24th, around 4:30 a.m., Andrew comes ashore.
Looks like our TVs are out. Maybe the power is out now for the duration of this. You can hear that outside. You can start to hear the roar outside. In the hallway of the Goldenberg house, winds outside, I think, are at least 100, 110 miles an hour or more. Aaron, are you okay? And there's the cat. And here's everybody here, just waiting out in the hall because we lost the plywood on the front window. But we are praying God will cover that. And we're just sitting back here resting in the Lord. In the hallway, we can feel our ears constantly pop from the pressure drops. Yes, Jonathan? Lord, we just thank you. We ask your protection. This is Stan at 8:30 in the morning. We have been through a night. This is our street. Trees down everywhere. The big tree, this was a huge tree in front of me, just one window broken on that car. Trees down everywhere. These are our sweet, precious neighbors. These shutters survived the storm. Every window covered with this type of shutter survived. But our house, which had wood shutters, the roof lifted off. And as you can see, we have no house. This wall fell on us, containing the refrigerator, the stove. This is the wall. Fell on top of us. Stove down there, cabinets, all fell on top of us. And that small space you're looking at, the mattress and everything, that's where we were pinned and protected during the worst part of the storm. Benjamin and Joseph.
Incredibly, 3 adults, 6 children, and a kitten emerge unharmed from the wreckage that was Stan's home. The scope of the disaster has not yet dawned on Miami. At the hospital, Barbara rests assured that her family is safe.
Can perhaps get the first look at what's going on up in the air from Sky 4.
The hospital had an emergency generator, so we still had power. And we saw all of the first footage of this destruction and storm, and we were in shock. The first areas they went through, they were kind of relieved, saying, oh, and just making interesting comments about how this car is thrown here and there. But they became much more sober as they went farther south.
This is incredible. It has just flattened this area.
It did not look possible that anybody could be alive. And that was just a mile or two from my house. And at that point, I really felt despair.
1, 2, 3, 4, 5, 6, 7, 8, and there must have been about, let's say, counting and trying to estimate at least 300 to 400 mobile homes here. The rest are just completely gone.
In the morning, my wife finally got through to somebody there just to find out I was okay. Somehow we both had a peace that each of us was okay. But I still remember the first time I got through to her on the phone. You know, I just wept. I mean, it wasn't just the excitement of getting through to her, it was me pouring out the emotions of what I had been through. I mean, we'd been through an incredible experience.
Andrew's storm surge wreaked havoc along the Florida coast, but its winds devastated an area larger than the city of Chicago. Some 135,000 dwellings damaged or destroyed. The homeless numbered 160,000. It seemed miraculous only 44 died. Not one official wind gauge survived Andrew's peak winds. No one knew how fast they had gusted. Intrigued, Dr. Ted Fujita, Mr. Tornado, flew to Miami to study the aftermath. Roofs ripped from homes. Trees snapped in half. Concrete beams carried hundreds of feet. Plywood embedded in a tree trunk. Fujita finds evidence of winds up to 200 miles an hour. But his most startling findings come from aerial surveys with local meteorologists. They point out narrow streaks of total devastation near areas with lesser damage. To Fujita, the patterns are eerily familiar.
Straight out that way. See the street? There, right across the lake. And those are the elements.
He develops a theory that the worst damage in Andrew was caused by mini-swirls, tornado-like rotations, brief but violent, embedded in the eye wall. The theory has personal meaning for Stan Goldenberg.
We never expected the kind of damage that we experienced. We had, not only were we in the area of some of the maximum winds of the storm, we had in addition, we believe, an area of more intense winds, probably caused by the mini swirls that Ted Fujita talks about. There was a strip right through my house of homes that were devastated, and I was right in that strip.
Stan would relocate his family to a new house. Parts of Florida remain scarred to this day. Andrew also ravaged the Louisiana coast, taking 17 lives. Finally, the storm would vanish over the mid-Atlantic states some 2 weeks after its birth. Andrew was America's costliest disaster, but it had a silver lining. It spared New Orleans, a city defined by water. Repeatedly flooded and drained over the past 3 centuries, the metropolis was built on swampland surrounded by the Mississippi River. Shaped like a bowl, the city's terrain rises near its edges and dips in its midsection to below sea level. Lake Pontchartrain crowns its northern shore. Over 100 miles of levees and flood walls up to 20 feet above sea level keep river and lake at bay. Massive floodgates fill the gaps. New Orleans has one of the best drainage systems in the world, powered by 21 colossal pumps. The city has known hurricanes in this century, but not a direct hit from a storm like Andrew. and not with up to 1 million people to evacuate over narrow bridges and causeways. Former meteorologist in charge of the New Orleans National Weather Service office, Bill Crouch, fears the levee system provides a false sense of security.
It's a two-edged sword because it protects the people's homes most of the time. But if water ever comes over the levees, it's going to get as deep as the levees are tall, and the lake would be 19 or 20 feet deep. This means that in parts of New Orleans that are below sea level, the water could be 30 feet deep. That is, you would not be safe even in a 3-story house. So those are the scenarios we look at, which would force people to go upward into the buildings downtown. And even using that refuge, it's my belief there would still be a great loss of life.
One day, 5, perhaps 50 years from now, a hurricane like Andrew might descend on New Orleans. The city might be jammed with tens of thousands of tourists, oblivious to the dangers of hurricanes. Evacuation would be ordered, and many would heed the call. But advanced weather could move in quickly and flood the causeway, knocking out bridges. A hurricane approaching from the southeast could fill Lake Pontchartrain with its storm surge. Water would rush over hurricane protection levees. Pumping stations would be overwhelmed. This grim scenario may be imaginary, but the threat is not. 100,000 might be stranded in the heart of the city. The City of New Orleans has enlisted federal, state, and local emergency management agencies to prepare for just such a nightmare. There are many other potential disasters along the U.S. coastline. It is only a matter of time before another great storm exacts its toll. Nature has given us fair warning. A gossamer veil of atmosphere is all that protects us from the sterile reaches of space. What we call weather is simply the Earth's attempt to balance heat and moisture around the globe. Swirling winds may spawn tornadoes and hurricanes, but they can also breed whimsy. A hay devil on a summer afternoon. Our home is a planet perpetually in the making, forever new. The same awesome powers that sustain life can also wreak destruction. It is up to us to be prepared. There lies the challenge and the delight of living on this dynamic Earth.
We hope you have enjoyed this presentation from the National Geographic Video Library.